Welcome to the deep dive. Today we're getting into what really makes up your drinks.
Yeah, we're talking raw materials, ingredients, additives, the whole lot.
We've looked through the info, and our mission is pretty simple. Figure out what these terms mean, why quality and storage are so important.
And maybe uncover some cool details along the way.
Okay, let's start with the basics. Raw materials, that's things like fruit, sugar, water, maybe alcohol.
Exactly. The foundational stuff. Then ingredients get added maybe to tweak the taste, texture, color, or, make it last longer.
Like acidulants for tartness or preservatives.
Precisely. And additives.
Yeah.
They're more about boosting overall quality or safety. Think antioxidants, maybe stabilizers or thickeners.
And there was one more, coadjuvants. Sounds a bit technical.
It just means things that help during manufacturing but aren't really in the final product, like yeast for fermentation or cleaning agents. They help the process.
Got it. And the quality of that starting stuff, the raw materials, that's crucial, isn't it?
Oh, absolutely. Poor quality, bad storage. It can ruin everything. Safety risks from contaminants, off tastes, weird textures.
Right. A whole batch could be spoiled. Makes sense.
It's a real domino effect.
Okay, let's zoom in on water. It's like 80 to 99% of most drinks.
Huge component. And it's doing more than just making things wet. Its properties affect taste, texture.
Even the pH level.
Yeah, that can impact how stable flavors and aromas are. Plus, you needed to dissolve all the dry powders and ingredients.
And it helps control temperature during production too, right? Like in fermentation or pasteurization.
Definitely. It's used everywhere as an ingredient for making ice, cleaning, sterilizing, even for heating and cooling.
Which touches on sustainability too, I guess, using water efficiently.
Big time. And there are strict regulations about water quality for beverages. For good reason.
The sources mention water, hardness, calcium, magnesium ions, causing issues.
Yeah, they can cause limescale, calcification in pipes and equipment. Reduces efficiency, costs more.
Okay. But it affects the drink itself, too.
It can. Those ions can react with other ingredients, potentially causing off flavors or stability problems like things precipitating out.
So how do producers deal with that? Demineralization?
Often, yes. Reverse osmosis, or RO, is pretty common.
How does that work, roughly?
Well, you're essentially forcing water at high pressure through a very fine membrane. It acts like a filter, separating out the ions and other impurities.
Leaving cleaner, more consistent water.
Exactly, a clean slate.
Then there's safety. Chlorination is common, right? To kill microbes.
It is. Chlorine gets into the microbial cells and disrupts their function, oxidizes components. It's effective.
Helps meet safety standards.
For sure. But the downside can be that chlorine taste or smell, or sometimes unwanted byproducts.
So there are alternatives.
Yes, things like ozone treatment, ozonization, or various types of filtration, UV light.
Well, ultrafiltration, is that like RO?
Similar principle, using membranes, but maybe targeting slightly different particle sizes. It removes tiny contaminants, improves clarity, reduces bacteria.
And ozone, how's that different?
Ozone is a powerful disinfectant, O3. It does its job killing microbes and then breaks down into regular oxygen, O2.
So no residue.
Generally, no taste or odor issues either, but requires special equipment to generate and use safely. It has its pros and cons, like cost.
Okay, moving on. Fruits and vegetables, obviously key for juices, sodas, smoothies.
Absolutely. They bring the natural flavor, aroma, nutrients, vitamins, minerals, great variety.
But availability can be tricky, right? Seasonal changes, cost fluctuations.
Definitely. That's why they're often processed frozen, turned into concentrates, or chemically preserved.
And get this, they're still biologically active after picking, still ripening.
That's right. Respiration and other metabolic processes continue. Ripening is complex, influenced by ethylene gas, temperature, humidity.
And there are different types of ripening. Climacteric.
Yeah, climacteric fruits like apples, bananas, tomatoes have a big surge in respiration and ethylene production that triggers ripening.
Which means you can pick them a bit early and ripen them later.
Exactly. Gives flexibility, extends shelf life if stored properly, often in controlled atmospheres.
And non-climacteric.
Those, like oranges, grapes, strawberries, ripen more gradually without that ethylene peak. They generally need to be picked when they're ready to eat.
So storage is super important to avoid spoilage.
Crucial. Temperature, humidity control, ventilation to remove ethylene, it all matters. You don't want climacteric fruits ripening your non-climacteric ones next to them.
Good tip. And cleaning is vital, too.
Absolutely. Simple cleaning removes dirt, but disinfection targets the microorganisms. Chlorine is often used here, too, in specific concentrations.
Then again, watching out for residues.
Right. Freezing is another big one. Lets you use fruit year-round.
But freezing itself can damage the fruit. Ice crystals.
Yes, especially freezing is slow. Large ice crystals damage the structure. Temperature fluctuations during storage are also bad. Causes crystals to grow, potential thawing.
And enzymes can still be active even when frozen.
They can, over time, causing breakdown, color loss, nutrient loss. Sometimes fruits are blanched or treated with acids like citric or ascorbic before freezing to minimize this.
So you get frozen pulps or diced pieces.
Right. Pulps are often just cleaned, maybe blanched, then frozen. Diced fruit might get an acid dip first, usually frozen quickly to -18 Celsius or colder.
And chemical preservation for pulps.
Yep, allows for shelf stability, sometimes even at room temp if preservatives like sorbates or benzoates are added. Sulfites are another option, though need careful labeling due to allergies.
What about concentration, making pulps thicker?
That's another key preservation method. Removing water lowers the water activity, making it harder for microbes to grow, plus it saves on transport costs.
Does how you concentrate matter?
Oh, yes. High heat at atmospheric pressure is one way, but vacuum concentration uses lower temperatures, which is generally better for retaining delicate flavors and aromas.
Wow, okay, so much goes into it. So wrapping this up, it's really clear that understanding all these components, raw materials, the ingredients, the additives, how they're handled, stored, processed, it's all interconnected.
Absolutely. Every step impacts that final beverage, quality, safety, and, well, enjoyment.
It really makes you think differently about what's in your glass.
Indeed. So, as you think about this whole journey, from a simple fruit or water source to the finished drink, what surprising part of that process makes you curious to know even more?